Okay, now we'll be doing problems that are involving numerical angles. Now this is the third part of explaining especially your identities in trigonometry, right? So don't forget to subscribe, like, and hit the bell notification for future videos, because if these are helpful for you, trust me, you have not seen nothing yet, because a lot more is coming from where this comes from. So right now we will be solving problems involving numerical angles. Now generally these type of problems will end up with one single value. Depends on the question. Let's not just limit them to one single value. So now let's start with just looking at a few examples, evaluating sine 35 by cos 35, as well as 10, 20, 10. Okay, let me read that again. It's evaluating the following fraction, which is your sine 35 by cos 35, right? All over 10 225 by cos 200. So this is your expression. And for the second question, you will be required to then look at another two sets of fractions for B, which is your sine 36 degrees over sine 12 degrees, right? Minus cos 36 degrees over cos 12 degrees. Let's start off with number A, right? So rewrite the question and take a chance, start writing it. However, I will be doing it for your benefit now, so we're carrying on for the solution. So your A, you will then have to start off by rewriting the question. So your sine 35 times your cos 35 degrees, right? And then all that over 10 225 degrees by cos 200 degrees. Now what we are going to do is we are going to expand, or let me just rather say we are going to turn the bottom angles into acute angles. So we keep the top part, the numerator, the same, sine 35 by cos 35. For the denominator, it's 10 open bracket 180 plus 45, and then you have your cos 180 plus 20. This is what I'm saying. You reduce your angles to acute angles. So we're reducing our angles to acute angles, and we therefore going to have your sine 35, which remains the same as the numerator, cos 35. As the denominator, we then have our 1045, because we have reduced our angles to acute angles, as well as by negative cos 20, because what? Cos is negative in the second quadrant. Now 10. So let's carry on. Sine 35 by cos 35, that remains the same. 1045 is equals to 1. Your negative cos 20 becomes your sine 70, because now we are going to look at cos 20 is equals to cos 90 minus 70, which is the same as saying sine 70. So that's how we came to the fact that sine 70, and therefore we write the numerator again, sine 35 degrees by cos 35. Now we are gonna use our double angle formulas to get the rest of the solution. Now your sine 70 becomes your sine 2 times 35. 70 is a double angle of 35, right? So sine 35 over cos 35, again the numerator you rewrite, and you then apply your double angle, which is you'll have your negative 2 sine 35 by cos 35 when you apply the double angles, right? So you apply the double angle formula right there. You will therefore have to cancel out what's at the top, because you see the numerator is the same as the denominator. So sine 35 degrees by sine cos 35 degrees is cancelled by your sine 35 degrees by cos 35 degrees. Hence you get your 1 over, or your negative 1 over 2. Now we'll carry on to the next. As you can hear, I have a bit of background due to the rain. And this rain is beautiful, so we love it indeed. Let's carry on though to the next question, B. The solution for B, on the other hand, is we have two fractions where you have your sine 36 over sine 12, all that minus your cos 36 minus cos 12. The first thing you need to do here is to come up with your lowest common denominator. For your lowest common denominator, you will first then have to calculate and say sine 36 by cos 12 after having taken your lowest common denominator, which is sine 12 by cos 12. And then so this will have your negative cos 36 times sine 12 as your second term. Then you will then use the compound angle formula. So for your compound angles, remember you are reducing. So you reduce your sine 36 times cos 12 minus cos 36 by sine 12 to sine 36 minus 12. You are directly using the correct procedure. So after having done this, I will say good luck for the rest of the question. It's raining quite badly, and I'm hoping that you will be able to finish the rest of the question on your own. Remember, if you struggle, subscribe to our channel, send a comment through. We are here for you until you write your exams. As you can see, I've finished the question. However, the audio is not going to be beautiful at all. Therefore, try to finish the rest of the question on your own. Thank you for watching.